Today we are going to study about colligative properties. Colligative properties are the properties of the solution, and it depends upon the concentration of solute molecules and not on the identity of the solute. What does it mean? It means if I ask you to dissolve 2 spoons of sugar in a glass of water and 2 spoons of salt in another glass of water. So for colligative property, it does not matter whether we are dissolving sugar or we are dissolving salt. What matters is in what concentration we are adding, how much amount of solute we are adding. Clear? So colligative properties are the properties of the solution that depends upon the concentration of the solute molecules and not on its identity. That means whether we are dissolving sugar or we are dissolving salt, colligative properties won't depend on that. For colligative properties, what matters is in what concentration or in how much amount we are adding that solute in a water. Here, as a solvent, we are talking only about water because we are studying chemistry in biological system only. So in biological system, the environment is aqueous, water. So we are talking only about water molecules. So what colligative properties are? These are the properties of the solution that depends upon the concentration of solute molecules. Now what happens when we add solute in a solvent or in a water? As the concentration of solute increases, the water concentration goes down. As the concentration of solute increases, the concentration of water goes down. So as the concentration of water goes down, therefore all the properties that depends on water concentration will start affecting. Now what are those properties? These are vapor pressure, boiling point, freezing point, and osmotic pressure. These are the 4 properties which are known as colligative properties that depends upon the concentration of water. Vapor pressure, boiling point, freezing point, and osmotic pressure. And how these properties get affected? These properties get affected by, as we add solute, there occurs lowering of vapor pressure, increase in boiling point, decrease in freezing point, and increase in osmotic pressure. So colligative properties are the properties of a solution that depends on the concentration of solute and not on its identity. As the solute concentration increases, the water concentration goes down. Hence, all the properties that depends upon the water concentration will start affecting. And what are those properties? Vapor pressure, boiling point, freezing point, and osmotic pressure. And how does it affect? Lowering of vapor pressure, increase in boiling point, decrease in freezing point, and increase in osmotic pressure. Now first, lowering of vapor pressure. Vapor pressure is the pressure exerted by the molecules of the solvent. If we add water in a closed container, so after some time, it will evaporate, it will start evaporating. The molecules on the surface of the water will first evaporate and they will convert into vapor. The pressure exerted by this vapor is known as vapor pressure. This diagram, when only pure solvent is present. So the molecules present on the surface are the molecules of this pure solvent only. So it can evaporate and form vapor. But if we add any solute, now on the surface, less of solvent molecules are present. This blue color molecule is the pure solvent molecule. So now as we add solute in it, so now less molecules of a pure solvent is present on the surface. So less solvent will now evaporate because on the surface less molecule is present. So evaporation will also become less. When the evaporation is less, the vapor formation is less. When the vapor formation is less, they will exert less pressure. So the vapor pressure goes down or it decreases, which is known as lowering of vapor pressure. Correct? So addition of solute in the solvent will decrease the vapor pressure. PO minus PS is called lowering of vapor pressure, and PO minus PS divided by PO is known as relative lowering of vapor pressure, where PO is the vapor pressure of pure solvent and PS is the vapor pressure of the solution. Next is elevation in boiling point. Now what is boiling point? Boiling point is the temperature at which vapor pressure is equal to the atmospheric pressure. Because of solute addition, the vapor pressure decreases. Hence, to match this vapor pressure with the atmospheric pressure, we have to increase the temperature or the temperature is raised. So because of which the boiling point elevates. What is boiling point? It is the temperature at which vapor pressure is equal to the atmospheric pressure. As because of addition of solute, vapor pressure goes down. Now to match it with the atmospheric pressure, the temperature should be raised. The formula is change in boiling point will be equal to the boiling point of pure solvent minus boiling point of the solution. What happens to freezing point? Decrease in freezing point. Why? Because freezing point is the temperature at which vapor pressure of liquid phase and vapor pressure of solid phase are equal. The formula is same like elevation and boiling point. Here change in freezing point will be equal to the freezing point of pure solvent minus freezing point of the solution. So because of addition of solute, boiling point elevates and there occur decrease in freezing point. Next is osmotic pressure. What is osmotic pressure? It is the pressure applied to stop the process of osmosis through a semi-permeable membrane. So it is the pressure exerted to prevent osmosis through a semi-permeable membrane. Now here in this diagram, a U-shaped tube is present with a semi-permeable membrane, and in this tube water is already present. Now say this is side A, this is side B. In side A, what is added? Glucose is added. That means solute concentration. We are adding solute molecules. So as we are adding solute molecules in this side, what we studied, more the solute concentration, the water concentration will go down. So in side A, what is happening? Water concentration is going down. So now side B will have a more of water concentration because here no solute has been added. So here pure solvent is present, because of which the side B has now more water concentration compared to side A, where water concentration lowers because glucose has been added or any solute has been added. What will happen now? Because of this, the water will pass through this semi-permeable membrane from B to A because B side has more of water concentration compared to A site. Now after adding solute, and always there occur flow from high concentration to low concentration. So from B side, water molecule will pass to A side. So hence we will see that after some time there occur increase in height of this solution in side A, and side B will go down. Now one more point to note here is, through this semi-permeable membrane, the water should only pass or the solvent should only pass. Solute should be non-permeable for this membrane. If the solute becomes permeable for this membrane, then solute will also start flowing. In that case, osmotic pressure won't generate. So for osmosis, the solute should be non-permeable. If the solute is permeable, it will also start flowing through the semi-permeable membrane. And in that situation, osmotic pressure won't generate. For example, ethanol, methanol, urea, and any non-polar solutes which pass through this semi-permeable membrane and hence cannot create osmotic pressure. Osmotic pressure can be calculated using the formula pi is equals to ICRT, where R is a constant, natural gas constant, T is a constant, absolute temperature. So that means osmotic pressure depends only upon I and C. What is C? It is the concentration of solute. It is solute concentration. What is I? It is a Van 't Hoff factor. What is a Van 't Hoff factor? Let's understand this with an example. Glucose, sucrose, proline, alanine all has I equals to 1. Van 't Hoff factor 1 because they are covalent molecules and hence do not ionize. NaCl, I is equals to 2 because it ionizes into Na and Cl. So 2 molecules or 2 particles. So what is Van 't Hoff factor? Van 't Hoff factor is a factor which determines that the solute is dissociating into how many particles. Here in NaCl, the solute is dissociating into Na plus and Cl minus. So formation of 2 particles after dissociation. So I is equals to 2 for NaCl. In case of CaCl2, I is 3 because after ionization, it gives 3 particles. Ca2 plus, 1 Cl minus, 1 more Cl minus. So 2 Cl minus, 1 Ca2 plus, total of 3 particles generate after the dissociation of CaCl2. So for CaCl2, I is equals to 3. Clear? So osmotic pressure means it is the pressure to prevent osmosis through semi-permeable membrane. In this, the solute should be non-permeable, otherwise it won't create osmotic pressure. Osmotic pressure depends upon concentration of solute and Van 't Hoff factor. What is Van 't Hoff factor? Van 't Hoff factor is the number of particles formed after dissociation of the solute. Now, one question from my side for you all. If in a U tube, on one side we add 0.2 molar of glucose and to the other side we add 0.1 molar of NaCl, then in which direction water will move? Will it move from glucose to NaCl side or will it move from NaCl to glucose side? For this, you have to remember the formula on which the osmotic pressure depends. Osmotic pressure depends on I and C. So you have to calculate I here and C here and then multiply. Then you have to calculate I here and C here and then you have to multiply and then see where the concentration is more. Do let me know in the comment section. If you found the video informative, please do like, share and subscribe the channel and hit the bell icon for the next video notification. Till then, stay safe, stay happy.